So now what we're going to do is we're going to find z-scores given a percentile, percent, or probability. So in the previous video, we were given the z-score, so I gave you a z-score. And now what we're going to do is find, we're given the z-score and we want to find the probability. Now we're going to be given the probability. Now we want to find the z-score. So let's just do one more example of finding a z-score before we get to the percentile and the probability. So let's say you want to find, we know that the z-scores are normally distributed with a mean of mu equals 0 and sigma equals 1. So let's say we want to, let's not just do part A. Let's just say we want to find the probability that z is less than or equal to 1.25. So let's say we want to figure out that probability. So again, the first thing that you want to be able to do is draw a picture. Okay, so here's my picture. My mean in this case is going to be equal to 0. And then 1.25 is a little bit greater than 0. Okay, and we're looking for everything that's less than this number. So we're looking at all of this area right here. Okay, so notice here that we need to have a couple of things. We need to figure out what mu is, which we already know, which is 0. That's my mean. My sigma, which is my standard deviation, that equals 1. My lower bound, and we also have to figure out what my upper bound is. So what is this going to be? So my lower bound in this case, so if I were to say this is negative infinity and this is positive infinity, notice that my lower bound is going to be the lowest part of this particular area. So here is all of my area. My lowest part is going to be negative infinity. Okay, my upper bound is going to be 1.25. Okay, because that's where my area ends. So what I'm basically doing, I'm going to use normal CDF. Okay, and then with my mean equal to 0, my sigma equal to 1, my lower bound equal to negative infinity, and my upper bound equal to 1.25. So on an exam or on a worksheet, I would like for you to either label all of this out here and then give me the answer, or just write that you're using normal CDF with all of this thing out. Okay, so now let's go ahead and figure out what this answer is going to be. So let's go to our calculator. So we're going to do normal CDF. So let me quit that. So second data, we're going to go down to distributions, go down to normal CDF. My mean was 0. My upper bound was 1. My mean was 0. My sigma was 1. My lower bound was negative infinity, so I'm going to leave it like that. And my upper bound was equal to 1.25. Okay, so I'm going to go ahead and calculate that. And I'm going to get 0.8944. So 0.8944, that's going to be my probability for this guy. So basically, the area that's under this curve is going to be about 89%. So if you want to think about it in terms of percentages, we can kind of think that this is going to be 89.44%, which actually makes sense because if the mean is right in the middle, then 50% of it must be below it. So my answer should be a little bit over 50%. Okay. So now let's say, now that we are given the probability, now we want to find the z-score. Okay, so now we are given probability, okay, and we want to find the z-score. Okay, well, not z-score, z-score. Okay, so how would you do that? So let's go ahead and try it out. So let's say you want to figure out, find the z-score. That is the 75th percentile. Okay. So remember what 75th percentile means. Well, let's first start off by graphing our curve. So let's draw a normal curve. Remember that z-scores still have a mean of 0. Okay, so here's 0. Now we're looking for what is going to be the z-score. So what value on the bottom will give us a 75th percentile? Now you remember, a percentile means how much percentage is below the graph. So in this case, this 75% 75th percentile is 75% of the data. So we're going to look for what value of z is going to give me 75% here. So we already know that my data is going to be 0.75 or 75%. So we want to figure out what is going to be the z value that's going to give us 0.75. Well, what we're going to do instead, we're not going to use normal CDF because normal CDF gives us the probability given a z-score. Now we want to find what is a z-score given the probability. So what we're going to use instead, we're going to use something called inverse normal. So if you see here, inverse normal is basically doing the opposite. Therefore, you have the INV. So if you go way up back to the page, you'll see that inverse normal, this function returns the x value given the probability region to the left of the x value. So basically, inverse normal is probability to the left, the mean, and the standard deviation. So that's what we need to have. So you're going to write inverse norm. And basically, what you want to figure out is the area to the left, the mean, and the standard deviation. Okay, that's what you want to figure out. All right, so what is this going to give me? Well, it's going to be inverse norm, area to the left. So how much area is to the left? Well, in this case, it will be this 0.75. So we're going to put 0.75 here. The mean in this case is equal to 0. The standard deviation is equal to 1. So what is this going to give me? So what we're going to do to access inverse normal, it's on the sheet, but let's go ahead and do it. So what we're going to do, we're going to press second data. We're going to go to distributions, and then we're going to go down to number 3, which is inverse normal. So press enter. Our area to the left is going to be 0.75. Our mean is going to be equal to 0, and our sigma equals 1. Okay, so our answer is going to be a z-score of about 0.67. Okay, so 0.67. So basically what this means is that z equals 0.67. If I were to use normal CDF and try to figure out what all of the area is, I will get 0.75. That's what that thing means. Okay, so that's what it means to have a percentile. So you can do it for any percentile. You can do it for like what is going to be the 90th percentile. So all you got to put is put 0.90 in there. Okay, so let me do one more example. So let's say we want to find the z-score that is the top 10% of the data. Okay, so let's try to figure out what is going to be the z-score that is the top 10% of this particular data. Okay, so the first thing we're going to do is draw a picture of the normal curve. So here my z-score is going to be at 0. We want to figure out what z-score is going to be the top 10%. So the top 10% is going to be right up here. So basically, we want to figure out what z-score is going to give me this top 10%. So this guy right here is 10%, which is basically as a decimal 0.1. Okay. So again, we're going to use inverse normal. Okay. So we're going to use inverse norm. Okay. Remember, it's area to the left. Okay, then we're going to figure out what the mean is, and we're going to plug in the standard deviation. Okay, so what is this going to give me? Okay, so it's going to be inverse norm. Now in this case, we want the area to the left. Notice that this thing is the area to the right. Now, how are we going to find this area? Because this is the area that I want. I want this particular area. So how are we going to do it? Well, I know that the whole thing is equal to 1. The whole thing is 100%. If this is 10% of it, then the other part should be 90%. Okay, if the whole thing adds up to 100%. So this guy is 10%, the other side is going to be 90%, which as a decimal should be 0.9. So that means the probability on the left-hand side is going to be 0.9. So that's what we're going to put here. The mean in this case is still equal to 0 because we're talking about z-scores, and z-scores are normal with a mean of 0 and a standard deviation of 1. And the standard deviation is going to be equal to 1. So we're going to go to our calculator. Second data, distributions, go down to inverse normal, and we're gonna click on, so this was gonna be 0.9, then we're gonna have 0, and we're gonna have 1. So my answer is gonna be equal to 1.28. So a z-score of 1.28 approximately. So I'm gonna write approximately. So that's what the answer would be. Okay. So nothing a lot to it to these problems. Just be careful when to use normal CDF and when to use inverse normal. Remember that normal CDF, when you use it, is that you are given an x value and you want probability. Okay. Inverse normal is that you're given a percent, a probability, or a percentile. And what you want to figure out is what is that x value, okay? So in the next video, we're going to do more problems with the normal distribution, because so far we've just been dealing with a mean of 0 and a standard deviation of 1, but they're not always going to be 0, 1. It's always going to be something different. So we're going to work with more word problems that deal with that, and also using normal CDF and inverse normal.